non-homogeneous differential equations. In our previous video we solved this equation, y double prime minus 5y prime plus 6y equals this. Now I'm going to do related problem. Example 2, solve y double prime minus 5y prime plus 6y equals, let's say, 7e raised to 3t. I just changed e4t to e3t. Solution. Like last time, we first considered the corresponding homogeneous equation. And we know how to solve this. We find characteristic equation, okay, which is r square minus 5r plus 6 equals 0. We factor and get values of r. Based on these two roots, we get r e raised to 2t and e raised to 3t. Okay, we got two solutions from two roots. And a linear combination is called complementary solution. We write yc c1 e raised to 2t plus c2 e raised to 3t is a complementary solution. Okay, that was not the issue. Okay, the issue was finding a particular solution, because the general solution, a general solution of this equation is yc, we learned in previous section, plus yp. So the issue is finding yp, and we are using the method of undetermined coefficients, and we did this in previous. Now, like last time, looking at the right hand side, looking at this non-homogeneous term, we guess let yc, we can call y just to make it easier, yc be just e raised to 3t a, some unknown a. Let this is a particular, sorry, yp. Let y be a solution of this equation, whole thing now, and we want to determine a from this. So for whole thing, okay, this is a solution, be a particular solution. Now we're gonna plug this here. For we need y prime, y double prime. So this is y. Let's find y prime. Derivative is 3a e3t. We also need second derivative. That will be now 3 times 3, 9a e raised to 3t. Now we plug these into the ODE. We are doing example 2 here. Y double prime is here, so this is 9a e raised to 3t minus 5y prime minus 5y prime. This is y prime multiplied by 5. 5 times 3, 15 a e raised to 3t plus 6y plus 6 times y, 6a e raised to 3t equals 7 e raised to 3t. Now we are trying to find the value of a, that's the undetermined coefficients. Okay, as soon as we are able to find the value of a here, this yp and yc plus yp will be the solution. Okay, now we looks like we run into a problem here. 9a plus 6a, 15a minus 15a, so we got 0 equals 7e3t. That's something wrong. So we are not able to find the value of a here, unlike in this previous question. So in the previous example, we were able to find the value of a just doing these steps. Then what went wrong here? The problem is from this homogeneous we got two equations, e raised to 2t, e raised to 3t, and look at this, e raised to 4t. That was not already a solution in example 1, but in example 2, look at the right hand side, we got e raised to 3t, but that was already a solution. That means, yeah, we are supposed to get 0 because E3T is a solution. Then when we plug in the left side, it's going to be 0 because E3T is a solution of this one being 0. So we need to modify our approach. If the solutions are already there, I mean this one we are supposed to, if this one is already a solution here, then just putting just by a constant in the front does not work. Now if you recall correctly from the previous section, when we have repeated roots like r equals 3 and 3, so what were the solutions at that time? That would like e3t and e3t, that would not work. We multiplied by t, right? We multiplied by t. So we're gonna apply the same technique here and hope that works. Okay, so whatever we did here is just a lesson learning here. So I'm gonna cross this out. It's one time work. Now you know E3T already here, so we should not proceed in this way. So let y equals, looking at right hand side here, E3T, yeah, that's the E3T, and A. But E3T is already there, then we just try to multiply by T. If there is another E3T, then we had to multiply by T one more time so that it works. So let this be A, this is YP by the way, and we can just call Y always. Let this be a solution. Now we do the same work, so we need to find y prime, y double prime, then y prime, in fact yp prime. But now this is a product of two functions, so we must use the product rule. So a stays here, derivative of t is 1 e3t plus t is t, derivative of this is 3 e3t. We need to find y double prime, so let's simplify this. E3t can be factored out. It's not necessary, but this makes our work easier. And y double prime is a product, so we can use product rule. Derivative of this one is this 1 plus 3t plus e3t, derivative of this, which is 3. Okay, and we can simplify this as well. E3t, E3t, A3. So 3a E3t can be factored out. 1 plus 3t plus nothing, just 1. So 1 plus 3t plus 1. So 2 plus 3t. 1 plus 3t plus everything out, that means 1. So 1 plus 1, 2 plus 3t. Now plug these into the ODE, which was y double prime minus 5y prime plus 6y equals, our example to 7 e3t. Okay, so y double prime is here, 3a e3t 2 plus 3t minus 5 times y prime. So y prime is here, we just multiply by 5. So 5a e3t 1 plus 3t plus 6y, 6 times y, 6 at e3t equals, right hand side is just 7 e3t. Hopefully we will be able to find the value of a. Now So we need to distribute here, distribute and combine. Okay, so this is 6a E3t plus 3 times 3, 9t, 9at E3t minus 5a E3t minus plus minus 15a t E3t plus 6at E3t equals 7 E3t. So 9 copies of at, negative 15at plus 6at plus 9 plus 6, 15 minus 15, so these 3 cancel. 6a et minus 5a et, 6a minus 5a, just 1a E3t equals 7 E3t. This implies, because they are same, we can divide by this E3t, or because they are never 0, so a equals 7. Okay, we got it. So the solution is, the general solution of this non-homogeneous equation is this complementary here plus particular where a is 7. Thus the general solution is y equals yc plus yp, and yc was here, c1e2t plus c2e3t, and particular solution was at e3t where a is 7, so 7t e3t final.